Today we'll be recapping everything we've done. So notice how I just put the same thing from the last CW. So take a moment, you can copy and paste it or just write it down from your last notes. This is just for your reference as you're working. These are the 5 main things you have to understand to pretty much do anything. But you're going to notice in today's problems we'll be using the accounting principle a lot. And that's because it can handle the really hard problems. These formulas straight up aren't super helpful. It's more utilizing it with the accounting principle is what's going to help you handle a lot of these really challenging problems. So let's get right into it. How many whole numbers less than 500? It's important. Can be formed using the digits 1, 2, 3, 4, 5, and 6. Repetitions are not allowed. Okay, so to do this, let's make 3 digits like that. And let's make sure it's less than 500. So if I focus on the first digit, I know I can't use the numbers 5 and 6, which means I have 4 choices left. I could use 1, 2, 3, or 4. Now for the next slot, it's a little bit tricky because you'll notice that I can now use 5 and 6. There's no restriction here, but I've already used a number here, which means I'm going to go down to 5. And for the last number, again, there's no restriction, but I've already used 2 numbers here, which means I'm going to go down to 4. So now you have to think, does this cover every possible whole number less than 500? Well, no. This is just case 1. This is a 3-digit number. There's going to be case 2. What if it's a 2-digit number? And in that situation, we think, are there restrictions? Well, no, because these are for sure less than 500. So you're just going to write 6 and 5. And then case 3, you have a 1-digit number, and that'd be 6. So notice how these are 3 separate scenarios. So you want to add them together to get your total, and this would be 116. Next problem. A license plate consists of 3 letters followed by a 3-digit number from 100 to 999. How many of these contain at least 1 vowel? Okay, let's put our slots down because there's 3 letters and 3 numbers. But then you're also going to notice at least 1 vowel. So remember, whenever you have at least 1, you want to do all minus none. That's going to be your key for approaching these. So first, let's calculate everything, meaning there is no restriction. So it doesn't say anything about repeating. So we're just going to put 26, 26, 26, because that's every letter. But then it says the next 3 is from 100 to 999. So this is going to be 9. I can't use 0 here. And then 10, 10. So this is our all. But then we're going to subtract our none, meaning no vowels. 1, 2, 3, 4, 5, 6. There are 5 vowels, A, E, I, O, U. So that's 21, 21, 21, and then 9, 10, 10. Plug that in your calculator, and then you get your answer. Next question. How many ways can 4 boys and 4 girls be seated in a row of 8 seats if the boys and girls must alternate? So again, let's draw the slots out. There are 8 seats, 1, 2, 3, 4, 5, 6, 7, 8. And the best thing to think about is just to try things. So let's just plug them in. Let's say this is a boy and that's a girl, and that continues. Boy, girl, boy, girl, boy, girl. How many boys are there? 4. How many girls are there? 4. Next is 3, because I've already used the boy. Next is 3, because I've used the girl. And we continue. So notice how this is clearly, that's 4 factorial times 4 factorial. Now you think, well, does that cover every scenario? Well, no, because this is boy, girl, boy, girl, boy, girl. What if it was girl, boy, girl, boy? So what we're going to do is grab this number, multiply it by 2. And now that covers every scenario, and we get 1,152. Now here's our last example, we'll do it together. 3 adults and 2 children are seated on a bench. How many arrangements are possible? If A, the children must sit together. So if the children must sit together, we're going to do our one-person technique. So these 2 children are going to be one person. So now total, there are 4 people, and we can arrange 4 people in 4 factorial ways. But we have to account for the kids moving around, so multiply by 2 factorial. Okay, so again, that's our 4 people, and then this is the kids moving around. So moving amongst themselves. Our answer is 48. Now go to B. The children must be separated, so opposite of this question. In A, they were stuck together. In B, they cannot be together. So this is kind of a creative question because it's actually an all minus none question. Meaning I can calculate everybody, which would be 5 factorial. That's your all. And if I subtract this answer, 48, this is all the seating arrangements where they're together. So if I take them out, that should leave all the ones where they're separated, and that would be 72. Okay, so try the rest of the questions and let me know if you get stuck on any.